Today we will start looking at ray optics. So that would be our first class, and then there would be a series of classes. So definitely subscribe to the channel if you are interested in understanding the ray optics. And of course, ray optics is very important. So questions are very simple, and questions are definitely asked, and they are very simple, very scoring, very quickly. You'll be able to solve these questions. So definitely keep practicing on Doorstep Tutor. So we'll start looking at ray optics with a very simple case. So we are not going to the concave lenses, the convex lenses, or the concave or convex mirrors. We are not even going there. We'll be looking at a plane mirror. Okay, so this is a plane mirror, and of course the mirror we always show. So okay, in the diagrams that I have, they are graphics is good. So but in paper we always show which side of the mirror has the silver coating. So this is necessary. Okay, so we'll show which side of the mirror has a silver coating. Now when you look yourself in the mirror, there is a person looking back at you. Of course, that person that is looking back at you we call the image. Okay, so the real person is the object. Okay, so that is the object. So we are the object. So this is us. So we are the object, and there is a corresponding person looking back at us, and this is known as image. So that is the first terminology. Okay, object and image. And this is about the ray optics. Okay, so there is a separate topic, wave optics, Huygens principle, and there are separate classes on that. So definitely look at those classes on DoorstepTutor. But this is about ray optics. So in ray optics, what do? We start drawing the lines emanating from a point object. So this is a point, this is just a point, and we make them strike the mirror. Okay, and in the case of lens, that would be lens. Now there is the laws of reflection. Because this is a mirror, there will be laws of reflection. In the case of our lens, it would be the laws of refraction. Okay, so because of the laws of reflection, our angle of incidence and angle of reflection would be the same, and because of which this ray which comes from here would go like this, would strike the mirror and would come back like this. Okay, and in this way we will be able to draw all the rays. Okay, so that is about the ray optics. Ray optics means it is also known as geometrical optics, and in that what are we doing? We are drawing the lines using the laws of reflection and refraction. We make these lines, and then we analyze using these lines where the image would be formed. So if I keep the object here, these lines, they will not meet anywhere on this side of the mirror. But if you retrace these rays back, they appear to originate from a point behind the mirror, and that is known as the image. Okay, so this is the image of the object, and in the next class we will understand that this is not the real image. Okay, so the real image, if these rays of light were to intersect some point later on this side of the mirror, okay, on this side of the mirror where the light is actually coming from, this is the lighted region, okay, and this is the dark region. Behind the mirror it is dark. Okay, so if the rays of light were able to meet in this region, okay, then we would have called the image as real image. Okay, but this image, because it is found behind the mirror where no light is actually reaching, but the image appears to come, the light to this eye who is looking from this side, your friend who is looking from this side, because the image appears to come from here, from behind the mirror. Okay, that is what it appears to us also. We think that the person is behind the mirror, but actually the person, there is no one who is behind the mirror, but it is a virtual person. This is a virtual image. Okay, so this is virtual. Okay, virtual image. And this is how, using the ray optics, we were able to trace our rays and reach at the image given this object. Okay, so that is the basic principle. Okay, now of course when we are doing these questions in exam, we want to be a little more systematic. We don't want to keep drawing the lines here and there where not, and try to come up with the image. So in the case of exam, what we'll do is that we will draw a line, and on that line we will place the object. Okay, and the object, it will not be a complicated thing, it will just be an arrow. Okay, so this is the very simple case. This is the arrow h, this is the arrow of height h, and we have placed it in front of the mirror. And of course, as I have shown before, okay, the mirror, we will show the silver of the mirror using these lines. Okay, now the there are two rays which I would need to create the image, okay, because the intersection of two lines would give me a point, and that only one point I need. Okay, so this is the only one point that I need, where is the tip of this this arrow. Okay, and to discover the point where the image would be formed, I only need two rays. I don't need to draw so many rays. Okay, so here I had drawn 3 rays, 4 rays, 10 rays. I don't really need that many rays. Okay, I only need to draw 2 rays, because in geometry, if the two lines intersect, I definitely would get a point. So I draw one ray which starts from P, and because it is incident at an angle of 90 degree to the mirror, it will come back, retrace its path. Okay, the angle of incidence will be equal to angle of reflection, and both will be 90 in this case. It will retrace its path back, and this will be the first ray. Very simple. The first ray is very simple. I chose a simple case, if you will. The second case also I will choose very simply. Okay, the line on which I have kept this object, I will call it principal axis. Okay, and principal axis, we will keep using this term. I will call it principal axis. And the second point, the second ray that I choose would start from point P. It will hit the where the mirror and the principal axis they intersect. Okay, and at this point it hits, because this angle theta and this angle theta have to be the same. Again, laws of reflection. I know that where this second layer of light would go. Now, if again, the thing is, these two rays of light are actually diverging, right? If you think about it, these two rays of light are actually diverging. So they will never meet, but they appear to meet behind the mirror. And the point where they appear to meet behind the mirror would be the tip of my arrow. Okay, and similarly, I can draw all the other paths as the first exercise. In geometrical optics, what we will do in the ray optics, what we'll do is that we'll try to see what relationship exists between the two heights h and h dash. Okay, so to do that, what we look at in this figure is that we look at these two triangles. So this is our first triangle, PQR. Okay, so triangle PQR, that is the first triangle, and the second triangle right here, this one. Okay, this triangle. We are going to look at these two triangles, P dash QR. So notice that this angle is theta, therefore this angle is also theta. Why? Because that is the intersection of two lines. Opposite angles have to be the same. Now, because this angle is theta, this angle is theta, this angle is 90 minus theta. And so is this angle. This angle is also 90 minus theta. Now this side QR is common. This angle and this angle are the same. This angle is same as this angle, with both are 90 degree, and therefore these two triangles, the triangle PQR and P dash QR, are congruent, which means that they are the same triangle. They will just overlap with each other. We can overlap the two triangles. If we cut these pieces, we will be able to overlap these two pieces on top of each other. Now what does that mean? It means that this height h and this height h dash are the same, and this P and this Q are also the same. So they have proved two properties of the mirror, that the image is formed at the same distance inside the mirror as the distance the object is put in front of the mirror. So if the object is put, let's say 10 meters in front of the mirror, the image will be formed 10 meters behind the plane mirror. So Q is equal to P. And by the same rule, by using the same congruency principle, we have also proved that the two heights of the two objects would also be the same. So h and h dash will be the same. Now there is another important property in optics which we will also understand at the same time as we are understanding this, and that is known as magnification. Okay, so we call it magnification, but it does not really mean that the things will always be magnified. They can be made smaller, they can be made larger, or they can be remain the same size. But it is defined as the size of the image divided by the original size, which means size of the object. So in this case, the only dimension that we have is the height. So we'll just do h dash by h, And of course, in the case of plane mirror, the magnification is 1. Like I said, we call it magnification, but it does not always imply that the objects would become larger in size. It might imply so microscope will have a magnification greater than 1, but that does not mean that magnification for all the lens combination, all the mirror questions, all the ray optics questions would always be 1. Although we call it magnification, it can come out to be less than 1, in which case the image would be smaller than the object. Okay, so with this we have understood the basics of ray optics, how to play with the lines, okay, how to use the various principles, and the only principles that we are really concerned about in this case were the 2 basic principles: the angle of reflection, the angle of incidence. They are always the same, and how to pick the right kind of rays for our purposes, so that our ray diagram becomes simpler, so that we can trace the image using simple rays. Okay, so with that understanding, now let us also understand at the same point, what does it mean? So we have already discussed the lateral magnification. Okay, so lateral magnification of the plane mirror is 1. Now let us understand what it means when we say that in the case of the mirror, the left and right are reversed. Okay, so what do I mean by left and right are reversed? So the common experience is, if the person is looking in the mirror and the person were to move his right hand, he would observe that the person staring back at him is actually moving his left hand. Okay, but that is not what is happening. Okay, it is not that the left and right are reversed. What is actually done by the mirror is that the things in front of the mirror, closer to the mirror, their image is formed first. Okay, so that is what is happening. So the things which are closer to the mirror, their image is formed first. So if my nose, right, so when I'm looking at the mirror, my nose is actually the closest object to the mirror. So my nose is the first thing that would be observed on the other side. Okay, and similarly then the rest this way. Okay, so what does it mean? That as I'm looking at the mirror, I am being turned inside out. Okay, so that is what is being done by the mirror. The mirror takes the closest object and puts it at the smallest distance. The image is formed also at the smallest distance. That is what we have understood, right? The P is equal to Q. So the object which is closest to the mirror, the image for that object would appear to us to be close to us. Okay, and that is what is doing. The mirror is turning things inside and out. It is not doing the left and right reversal, and because of that inside out behavior, the right hand of the person becomes the left hand of the image, because of that inside out behavior. It is not because the right hand physically becomes left hand. That is not what is happening. Okay, so hopefully things are become very, very clear. We will be solving several numericals in the forthcoming class, and like I said, those numericals would be very, very scoring. But before we solve that, you can go ahead and practice numericals on DoorstepTutor. Okay.